Hello, my name is Hasan Gecekuşu. I'm a student in Bilkent University at Industrial Engineering Department. Today I'm presenting my Physics 102 experiment on determining the magnetic probability of free space, denoted as nu zero. The goal was to verify the relationship between a coil's magnetic field and the current flowing through it. So here's my setup for my experiment. At first I connected a DC supplier to my circular wire coil. After that I made a stand for my coil to make it stable. Then I calibrated my Gauss meter, which measures the magnetic field, and after that I made a stand for it too, because at the center of the coil there is the maximum magnetic field, so it should measure it from exactly at the center of the coil. According to the PHYS102 law, the magnetic field B at the center of a circular coil is given by B equals nu zero times N times current over 2R. In my setup, I used a 320 turn coil with a radius of 6.25 centimeters. I connected this to a DC power supplier and used a magnetic field sensor to take measurements at the center. I varied the current from 1 ampere to 3 amperes in increments of 0.5 amperes. To minimize random error, I measured the magnetic field 3 times at each current level and calculated the average. The plot of magnetic field versus current shows a clear linear relationship as predicted by theory. The slope of this line was approximately 0.1 Tesla over ampere. Using the formula nu zero equals 2 times r times slope over n, I calculated an experimental nu zero of 4 times 10 to the power minus 5. While the linear trend was successful, my experimental value for nu zero was significantly higher than the accepted value, leading to a large percentage error. This was likely due to external magnetic fields in the room, sensor misalignment, or calibration issues with the magnetic field sensor. In conclusion, this experiment successfully demonstrated the linear relationship between current and the resulting magnetic field, which aligns with the theoretical predictions of the PHYS102 law. Although the trend was correct, my calculated value for nu zero was 4 times 10 to the minus 5, which is significantly higher than the accepted value. This resulted in a percentage error of approximately 3000. As I have discussed, this discrepancy likely stems from human errors, calibration mistakes, and the influence of external magnetic fields in the environment. However, the primary objective of verifying the proportional relationship between current and the magnetic field was achieved. For future experiments, employing more precise measuring techniques and better sensor shielding will yield much more accurate results. Thank you for listening.